Hello, everybody. Welcome to our class. Can everybody hear me okay? Okay, great. So this topic is actually our last topic since this is the second to last class, and we're going to be going over polynomials and specifically Vieta's formulas. So our warm-up is, what are the roots of x squared minus 2x plus 1 equals 0? And here roots means solutions. So you can rewrite this equation as x squared. Okay, hang on, I'm lagging. Okay, I'm kind of lagging really bad. Okay, x squared minus 2x plus 1 equals 0. So basically you have to solve this equation. So you can technically solve any quadratic equation with the quadratic formula, but a lot of times you can find a way to factor it so that you don't need the quadratic formula. Okay, so the way you solve this is you actually notice that the left-hand side is equal to x minus 1 squared. Because if you expand x minus 1 squared, then you get x squared minus 2x plus 1. And this whole thing is 0 only if the thing in the middle is 0. Or x minus 1 is equal to 0, which means x equals 1. So quadratics always have two solutions. And since we only found one solution here, that means this one solution is called a double root. Basically, it's a root that appears two times. So our only solution is x is equal to 1. So basically, x minus 1 squared is only equal to 0 if x minus 1 is equal to 0, which means that x is equal to positive 1. And any quadratic or polynomial with a degree of 2, which means the greatest exponent is 2, that polynomial always has two solutions. If you can only find one solution, then that means that one solution is called a double root. So it kind of counts for two solutions. So is everybody okay with our warm-up? Yes. So for example, a cubic or a polynomial with a power of 3, which has this as its greatest term, always has 3 solutions, and so on. Okay, so yeah, that kind of leads us into the next slide, which is, what is a polynomial? So a polynomial always takes the form of f of x, for example, equals a1 times x to the n plus a2 times x to the n minus 1 all the way down to an times x to the 1 plus an plus 1. So a polynomial is essentially the sum of a lot of different power functions. So you can have x to the 0, you can have x to the 1, you can have x to the 2, ... And it's basically a sum of different numbers of each of these. And of course, x represents your variable. So like if I gave you the function f of x is equal to x cubed plus 3x squared minus 1. And I asked you to plug in x equals 1, then what would this be? So f of 1 is you replace all the x's you see with 1's, and you get 1 cubed plus 3 times 1 squared minus 1. And then you would get 3. So does everybody understand this? Oh, f is common notation to denote a function. So basically, f stands for function. So there is a function of x that when you input a certain value of x, it outputs a certain value. So in this case, for the function f, if I plug in the number 1, then out comes the number 3. Well, I already gave you what f of x is, so it's right here. F isn't like a variable, it's notation. So I got 3 from plugging 1 into x cubed plus 3x squared minus 1. So here I have an x cubed, and wherever I see an x, I plug in a 1 if I asked you to find f of 1. So that would give you 1 cubed. And 3 times x squared here would give you 3 times 1 squared. Yes, x is the variable. The equation on top is the general form of a polynomial. So polynomials can basically be as big as you want. You could have a polynomial, for example, saying x to the 999 minus x to the 437 plus 2 times x to the 21. So for example, this right here is also a polynomial. I can give you a value of x, and you plug x into this green thing, and you give me an output value. So this is the general form. All of these coefficients in front of the x's can be any real numbers. So in this case, this would be 1 times, 1 times. And the exponents of all the x's have to be whole numbers. So they can't be like, for example, fractions or decimals. So any questions? So this class, we're going to be focusing on just solving quadratics. So those are functions of the form something times x squared plus something else times x plus a constant. So we're going to be learning how to solve these types of equations. A constant is just basically a number that's not in terms of x. So for example, 5 is a constant, negative 21 is a constant, 10.5 is a constant. But something like 3 times x is not a constant. because I can give it different values of x, and it would give me different outputs. Yes, basically a constant is just something that doesn't change. Yeah, we'll be briefly going over the quadratic formula. But a lot of the problems we'll be doing actually doesn't need it, because the quadratic formula is typically just like a uh, ditch method in order to solve quadratics. If you can factor a quadratic into a product of, for example, x plus something times x plus something else. If you can get this form into this by factoring, then you don't need the quadratic formula, because either x plus m is 0 or x plus n is 0. So then x equals negative m or negative n. So any questions for this page before we move on? Okay, so let us move on. This will hopefully become clearer as we learn more about polynomials. Oh, how do you solve quadratic equations? So if I have an equation or a function f of x is equal to ax squared plus bx plus c, where a, b, and c can be any numbers, and x is the variable, then the roots of this quadratic are x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you plug in your values of a, b, and c into this formula you see right here, it will give you the solutions of x. And these solutions are what you plug into ax squared plus bx plus c to give you an answer of 0. So typically you won't need the quadratic formula, because a lot of times you can actually factor. The quadratic equation is just a way to find the roots of a quadratic. So for example, if I gave you, let's say, the function 3x squared plus 4x minus 5 is equal to 0, and I told you to solve this equation, what would you tell me? Right, you would use the quadratic formula if you don't see a way to obviously factor it. So if you use the quadratic formula, x is equal to negative b, well, b here is 4, which means I plug in negative 4, and plus or minus the square root, b is once again 4, so 4 squared minus 4 times a is 3, and c is negative 5. And I divide the whole thing by 2 times a, which is 2 times 3. So this huge monster of a number here would be the answer to the equation. So if I simplify this, and this gives you two solutions, by the way. This gives you negative 4 plus the square root of 4 squared minus 4 times 3 times negative 5 over 2 times 3. And it also gives you negative 4 minus the square root of 4 squared minus 4 times 3 times negative 5 over 2 times 3. That's what the plus or minus sign means. If I plug either of these numbers back into our original equation here, then the left side would equal 0. That's basically what the formula is telling you. So any other questions? So f is basically notation saying f of x is a function. So let's imagine here that f of x is one big machine. And okay, so let's say we have this huge machine that's f of x. Okay, the function f. So if I drop any number x into the machine, I should be able to get a different number out of the machine once the machine does certain things to our number x. So I would maybe get the number y, right? So for example, if I drop the number x equals 1, if I dropped 1 into this machine, then the function f of x would do stuff to the 1. In this case, what it would do is it would replace every single x with the number I dropped in, 1. So a times 1 squared plus b times 1 plus c. And if you simplify this, you get a plus b plus c. So then it would spit out this number as y. So the f here is just notation. You don't need to worry about it. It's just telling you that you're plugging 1 into the function. And that function is ax squared plus bx plus c. So do you understand now? Yeah, basically. Yeah, so it basically, every single number you plug in, it does the same thing to it. It replaces every single x in the equation with that number, simplifies it, and then spits that number out. And that number is equal to f of x. That's how we define it. Okay, so let's move on. What are the roots of x minus 5 is equal to 0? So basically, what x can I plug into this equation so that it's true? Okay, so this is a pretty easy one. So you have the equation x minus 5 is equal to 0. So typically you want to isolate the variable x, and you can do that by adding 5 to both sides of the equation. And the negative 5 and positive 5 cancel out, and you get x is equal to positive 5. Okay, so you'll notice that x minus 5 is also a polynomial. It's a polynomial of degree 1, which means that the highest degree of x, the highest power of x is 1. X to the 1 minus 5. And the number of solutions a polynomial has is always equal to the degree of that polynomial. So since the highest exponent of x in this expression is 1, that means there's only one answer. And our one answer is right here, x is equal to 5. So does everybody get that? Okay, so let's move on to this one. What are the roots of x squared minus 5x plus 6 is equal to 0? Okay, so first let me ask you, how many solutions are there to this equation? Just by not doing anything to the equation, if you just look at it, how many solutions do you think there are? And how do we know that? Right. So we know that because the exponent on the left here is 2. So it must have 2 solutions. So we can already predict it's going to have 2 answers. But let's go ahead and solve this. Technically, what you could do is you could use the quadratic formula. You could say x is equal to negative b plus or minus the square root of b squared, which is 25, minus 4 times 6 times a, which is just 1 all over 2 times 1. And you would get this huge messy thing. And you would simplify this down to plus or minus 1 over 2. And you would either get 3 or 2. So you could do it that way. Or you could be smart about it and you can notice that x squared minus 5x plus 6 actually factors as x minus 2 times x minus 3. And since we're given that this is equal to 0, anything times 0 is going to be 0. And that's the only way to get 0. So either this is equal to 0 or this is equal to 0. So if x minus 2 is equal to 0, then we get x is equal to 2. And if x minus 3 is equal to 0, then we get x is equal to 3. And so these are our 2 solutions. So any questions? Okay, so it takes a little practice to be able to see factorizations. There is a method that you can use. I know that a lot of people use different methods, but the way I do it is I make a little box here. So let's make a little box, okay? And right above this, let's write our equation x squared minus 5x plus 6 is equal to 0. So we want this to be able to factor into the form x minus m times x minus n is equal to 0, right? So next what we're going to do is we are going to try to make the numbers, hang on, m and n are the solutions to the equation. So we already found out here that m is equal to 2 and n is equal to 3, which means if you plug 2 and 3 back into the original equation, you would get 0. Okay, so let's make the number in this box and whatever's in this box multiply up to 1x squared. And let's try to make the number in this box and the number in this box multiply up to positive 6. So is everybody following so far? So if we think about ways that two numbers can multiply up to 1x squared, then there's really only one intuitive way to do it, which is to say that this box is, hang on, this box is 1x and this box is 1x, right? And we actually get those x's from here. So this is kind of like expanding x minus m times x minus n. And over on the right side, what two numbers would add up to 6? I mean, multiply up to 6. Can someone think about two numbers that would multiply to 6? Okay, so we could try 2 and 3. If we try 2 and 3, then let's put positive 2 here and positive 3 here. Now what you're going to do is you're going to look horizontally. So you see one row here and one row here, right? So you're going to combine these two rows together. The first row tells you x plus 2. The second row tells you x plus 3. So let's try to expand this and see if we get x squared minus 5x plus 6. So can you guys expand this for me and tell me what you get? Okay, so if you expand it, you get x squared plus 5x plus 6. And you'll actually notice that these two equations don't match, right? So that means something somewhere went wrong, because our goal is to have these two equations match. So that means that the original numbers here and here, we assumed wrong, right? So we're going to have to go backwards and try to pick different numbers that multiply up to 6. So can anybody give me two other numbers that multiply up to 6? Okay, let's try 1 and 6, for example. Well, let's write in +1, +6. So if you look at it horizontally, what you'll get is x plus 1 times x plus 6. And can you guys expand this for me? Well, we get x squared plus 7x plus 6. And once again, these two equations are not the same, which means we have to go back and try different numbers. So let's try different numbers here. And the two numbers that actually work are -2 and -3. Because if I expand x minus 2 times x minus 3, I'll get x squared minus 5x plus 6. And because these two equations match, then I know I found the factorization. This right here is the factorization, which means it's equal to x squared minus 5x plus 6. And since we're given that this is equal to 0, either x equals 2 from what this tells you, or x equals 3 from what that tells you. And so 2 and 3 are your two different solutions. So does everybody understand that? Okay, great. So actually a tip here is that when you're looking for these two numbers that multiply up to the last term that you want, you'll notice that -2 plus -3 is actually equal to -5, right? So that's a little tip there. That'll make it faster for you to figure it out. So that was just a quick overview of how to factorize quadratics. It might still not be super clear for some of you, mainly because I wasn't planning on talking about that today. But if you want, I can actually go over this in more detail next week instead of what I planned for next week. So would you guys like that instead? Yeah, okay, so I'll slow it down for next week. And let me just see what we actually have in store. So this right now is our second to last class. Our last class is next week. So the good news is that we have more math classes. If you visit our website, I think we have 2 or 3 other math classes that are about to start. So that's a good thing. This next question asks, what are the roots of x squared minus 5 equals to 0? Can we learn math with you? I am not sure. If there's enough demand for another math class, then maybe. But it depends on how many people here want another math classes with me. I can post a Google form on the Google Classroom and you can fill that out and let me know. So I'll do that. Okay, so let's just try to solve this question really quick. We have a minute. What are the roots of x squared minus 5 equals 0? Okay, so if you add 5 to both sides, you get x squared is equal to 5. And if you take the square root of both sides, you get x is equal to the square root of 5. But whenever you take the square root or square of an equation, you have to be careful because positive square root of 5 is the solution, but negative square root of 5 is 2. So these are actually the two solutions. Okay, so we have less than a minute, so that was a great class, everybody, and I hope to see you next time. Bye, guys. No problem. So I'll post the Google form. If you want another class, you can fill it out on Google Classroom. So see you guys.